The mission would use a solar electric propulsion (SEP) system to launch a Mercury orbiter and lander (MOL) spacecraft, which would consist of a modified Orion capsule and a lander module derived from the Lunar Gateway. The SEP system would provide efficient and flexible thrust for the long journey to Mercury. The launch date would be January 5, 2025, and the flight duration would be about 2.5 years. The spacecraft would use a series of gravity assist maneuvers around Earth, Venus, and Mercury to reach its destination. It would also perform several course corrections and trajectory optimizations along the way. The orbit insertion around Mercury would be on July 15, 2027, after a total of 923 days in space. The MOL spacecraft would enter a highly elliptical orbit around the planet, with a periapsis of about 200 kilometers and an apoapsis of about 15,000 kilometers. The orbit would be inclined by 90 degrees to the equator, allowing the spacecraft to observe both the day and night sides of Mercury. The lander module would separate from the orbiter module and descend to the surface of Mercury on August 1, 2027. The landing site would be near the North Pole, where there are regions of permanent shadow that may contain water ice and other volatiles. The lander would carry 2 astronauts and a rover, as well as various instruments and experiments. The surface mission would last for about 14 days, during which the astronauts would explore the landing site, collect samples, deploy experiments, and communicate with the orbiter and Earth. The rover would assist the astronauts in their tasks, as well as autonomously explore the surrounding terrain. The lander would also serve as a habitat and a launch platform for the ascent stage. The ascent stage would lift off from the surface of Mercury on August 15, 2027, and rendezvous with the orbiter module in orbit. The 2 astronauts would transfer to the Orion capsule and prepare for the return journey to Earth. The lander module would remain on the surface as a permanent outpost. The return to Earth would be on February 28, 2029, after a total of 1,510 days in space. The Orion capsule would separate from the orbiter module and re-enter the Earth's atmosphere, while the orbiter module would remain in orbit around Mercury as a relay satellite and a scientific platform. The mission would have several scientific and technological benefits, such as advancing our understanding of Mercury and its origin, testing the human endurance and performance in extreme environments, and demonstrating the feasibility of using SEP and lunar-derived landers for future exploration.